Space is really, really big, and aliens are not magic. These are the two critical points to consider if you really want to think about UFOs as spacecraft from distant star systems. They are also the most important points to consider if you want to imagine humanity getting out of the solar system and building a galactic federation. The first point forces us to confront the insane distances between the stars. The second point forces us to deal with the physics problems involved in crossing those distances, even if we don't know what their solution might be just yet. Let's take a leap into the unknown, but keep our science crash helmets on. The question we want to ask is this: if the UFOs that we've seen on Earth, and some claim are real, were spaceships from other star systems, then how might they, or us, or anyone cross the great interstellar void? Astronomers measure interstellar distances in light years, which is the distance light travels in a year and spans 6 trillion miles. That's a 6 with 12 zeros after it. You have probably walked a mile, driven hundreds of miles, and flown thousands of miles. All this takes you only through the first 3 zeros. The other 9 require a major act of imagination. If you are looking for an earthly comparison for the distance a light year comprises, it is the same as traveling all the way around the Earth about 32 million times. Another way to understand a light year is to consider the distance from the Sun to the edge of the solar system. If the Milky Way galaxy is our local city of stars, then the solar system basically constitutes the house we were born in. Think of Earth as one room in that house. In 2006, we launched the fastest space probe ever developed, New Horizons, and sent it to Pluto, which can stand in as the edge of the solar system. The distance to Pluto is about 2,000 times shorter than a light year. Now here's the point to ponder. Even though New Horizons was hurtling through space at 36,000 miles per hour, it still took 10 years to reach Pluto. From that factoid, we can conclude that it would take New Horizons at least 20,000 years to cross a single light year. While that's a very long time, it doesn't even get us all the way to interstellar distances, since there is really nothing out there 1 light year away. You have to travel almost 4 times as far to reach the nearest star, Alpha Centauri. So, a journey by New Horizons to Alpha Centauri would take 80,000 years, and that is the closest possible home for UFO flying aliens. Most importantly, note that most stars are way, way farther away than Alpha Centauri. The Milky Way galaxy is about 100,000 light-years across. That means even our local stellar neighborhood has to be measured as thousands of light-years across, or tens of millions of years of travel time for our fastest space probes. All of this serves to confirm that, yes, space is big. Or, as Douglas Adams put it, space is vastly, hugely, mind-bogglingly big. If UFOs really are interstellar visitors, then these are distances they must routinely cross. They are also the distances that we, humans, must learn to cross if we are to become an interstellar species. Now here's the big kahuna of an issue. Any attempt to cross those distances runs into a fundamental fact about the universe. Nothing can travel faster than the speed of light. This is not just a fact about light. It's a fact about the very nature of physical reality. It is hardwired into physics. The universe has a maximum speed limit, and light just happens to be the thing that travels at it. Actually, anything that has no mass can travel at light speed, but nothing can travel faster than light. This speed limit idea is so fundamental, it is even baked into the existence of cause and effect. Now, there may, of course, be more physics out there we don't know about that is relevant to this issue. But the speed of light is so important to all known physics that if you do think UFOs equal spaceships, you cannot get around this limit with a wave of the hand and a "they figured it out." You've got to work harder than that. Given these insane interstellar distances, how might we extrapolate from the physics we do understand to see how those aliens, or us in the future, could cross the cosmic void? There are a few possible solutions to the problem of interstellar travel. One is cryosleep. Depending on their biology, the lifespan of our hypothetical aliens might be shorter than the centuries-long journey required for slow, sublight speed travel between the stars. That is certainly the case for us. One obvious answer to this dilemma is to do the bear and winter thing and just hibernate through the trip. Cryosleep technology would basically freeze the body's metabolism, or at least slow it down for the duration of the journey. Despite being a staple of science fiction, no one even has come close to getting this to work for higher animals like mammals. Still, it is the kind of solution that doesn't require magical new physics to exist, maybe just magical new biology. Also, if post-biological life is really a thing, then maybe some aliens switch to silicon-based machine forms, and thus, the question of long timescales is no longer an issue. Another option could be light sails. While no one has ever been blown down the street by a ray of sunlight, photons or light particles do exert a force, a push on matter. If you could extend a large enough and light enough sheet of material in space, you could use the sun to propel you through space. The idea of such solar sails has been around for a long time, but in 2016, Philip Lubin of UC Santa Barbara proposed using giant and very powerful lasers, rather than the sun, to provide the light for interstellar sailing. With a large enough laser positioned at the departure point, you could accelerate a sail and the ship tethered to it up to nearly the speed of light. That means you could cross the distance between nearby stars in years or decades, not centuries or millennia or longer. The billionaire astronomy philanthropist Yuri Milner was so taken with this idea that he gave $100 million to its development in a project called Breakthrough Starshot. The hitch for UFOs using this technology is that you need another giant laser located in the target star system to slow you down if you wanted to stop for a visit. Third option is wormholes. If the speed of light limits how fast you can travel through space, then maybe the best solution for interstellar travel is giving up on the through. That possibility was the gift Einstein gave us with his theory of general relativity. In relativity, space is not an empty void. Merged with time into a single entity called space-time, it constitutes a flexible fabric that can be bent, stretched, and folded. Wormholes represent a kind of space-time tunnel that uses this folding to join two regions of the galaxy together that only appear to be widely separated. While such wormholes are most definitely allowed in the theory of general relativity, they are unstable. That means once formed, by whatever means, natural or otherwise, they would almost instantly slam closed. So if aliens wanted to use wormholes to build a kind of galactic transit system, they would need to find something physicists call exotic matter. This is stuff that has true anti-gravity properties. It could force the two mouths of a wormhole to stay open, thereby connecting two distant parts of the galaxy. The big hitch here is that exotic matter is not real. It is just a term that you can add to the theory of general relativity equations and change how they behave, but it is there, within the framework of known physics. If exotic matter turns out to be more than just a physicist's pipe dream, it could serve as the means for fast interstellar travel. Warp drives, also known as hyperdrives, the darling of science fiction writers everywhere. If aliens could build a warp drive, they would once again be using the fabric of space idea from Einstein's theory of general relativity. The drive does not push you through space from one place in the galaxy to the other. Instead, it creates a warp bubble that stretches and then relaxes the space-time around you. You do not travel through space faster than light. Instead, you warp and unwarp space faster than light speed. While nothing can travel faster than the speed of light through space, space-time itself can move at whatever speed it likes. The nice thing about warp bubbles is that they, like wormholes, are also theoretically possible, as Miguel Alcubierre showed in a famous 1994 paper. The Alcubierre drive concept has received considerable attention since then and can be extended a number of ways. But there are, as you might expect, some really big problems with warp drives, or else we would have them already. Once again, you need that exotic matter stuff that probably does not exist. Even more problematic is that warp bubbles may generate huge shock waves of high-energy gamma rays as they move. Once you dropped out of warp, this blast of energy would fry everything in your path and sterilize any planet you were visiting. If that is the case, let's hope that any Alcubierre drive-equipped aliens don't pop in for brunch anytime soon. Lastly, we have quantum mechanics. Quantum physics, which is our uber-powerful theory of the atomic and subatomic world, is notoriously weird. With quantum mechanics, physicists are forced to talk about particles being in two places at the same time, or two particles instantly affecting each other, even though they are on opposite sides of the universe. I could go on for a while about how strange quantum mechanics is compared to our common sense understanding of how space, time, matter, and energy are supposed to behave. Even after 100 years of developing quantum mechanics into the most accurate and potent physical theory ever created, and after becoming the ground upon which all our electronic miracles are built, we still cannot say we understand what it is telling us about the nature of reality. Personally, I think that is pretty cool. What all this means for interstellar travel is that there might be something hiding in quantum mechanics that allows you to bypass theory of general relativity's apparent restrictions regarding space-time. Some folks who are working on merging quantum mechanics and general relativity into a theory of quantum gravity even believe that space-time may not be fundamental. Instead, it might emerge out of some deeper aspect of reality. So, quantum mechanics could have some tricks up its sleeve that a sufficiently advanced alien species might know about and exploit for interstellar travel. But be careful. There is no physics here other than noting some weirdness. So that's it. That's all we or they have in terms of solutions to the problems posed by interstellar travel. Now, a good science fiction writer might find other creative ways to imagine getting from one star to the next. This video, however, pretty much exhausts what a scientist would propose as being possible based on what we know about reality. The important thing to note is that once you go past the first two possibilities, then Elvis, in terms of experimentally validated physics, has most definitely left the building. Thanks for watching. Please like the video, subscribe to Nebulix, and comment your thoughts on interstellar space travel. Keep watching more interesting videos by clicking on your screen now.